Hello everyone, this is Friday's lecture from October 4th, and the topic is the product and the quotient rule. So far we know how to differentiate basic functions, and we can differentiate more complicated functions composed of those by applying the differentiation rules. Yeah? And so far we have the rule for multiplication by a constant and the rule for addition and subtraction. And today we'll start with the product rule and the quotient rule. And then we'll get in the next lecture we'll get the chain rule for the composition of functions. Okay, and then this is how it goes. This is easy, and then it gets harder. Maybe it's not a nice word. Yeah, it's more fun. Okay, so like that. Okay, and now we will learn the product and quotient rule. Okay, so addition was easy. When we add two functions, we just split and take the derivative separately. How would that be? So our hope is x times sine of x prime is that x prime times sine of x prime. That would be 1 times cosine x. And the answer is no. Really no, I'm doing this part so you don't make this mistake, okay? We have a whole page about this, why this is wrong, okay? Okay. So, and this is what Leibniz, who was one of the inventors, one of the inventors of the derivative, thought at first f times g prime is f prime times g prime, and he then scratched it out. Okay, so this is not true. Okay, so let's check what we would get in this case with x squared, right? So we know x squared prime is by the power rule 2 times x. What would that be if we could use this simple rule? So if it was like that, so x times x prime would be then x prime times x prime would be 1 times 1 is 1. Well, this is not 2x. Okay, so this is wrong. Yeah, again, no. Really no. No. Okay, so, and it gets even worse. So f is 1 times f, so what would that give us? So f prime for any function would then be 1 times f prime is 1 prime times f prime is 0 times f prime. But 0 times something is 0, so that would be 0. So that would mean actually the derivative of any function would be 0. Yeah, that would make our life easier, yeah, but also less interesting. Yeah? So really no. Okay, so the question is what should be the correct rule, so it cannot be so simple, yeah? And then it turns out if f and g are both differentiable, then the rule is f times g prime is f prime times g plus g prime times f. And there's a proof for that using limits, yeah? You can find this proof in the filled lecture notes. I won't do it here, but if you want to continue with Calc 2 and Calc 3, you should study this proof. Okay. So so the idea would be we would write what is the limit, what is the derivative, f times g prime is the limit h goes to 0 of f times g x plus h minus f times g of x over h, and then we would use this trick, this is mentioned here, and we would split it all and then would get the rule which is on the top. Okay, and you can find this in the field lecture notes. Okay. Okay. So we can use a mnemonic to execute the rule. So here it is, f times g is x times sine x. This is an example, yeah, and we want to find the derivative. I write down the rule again here. F times g prime is f prime times g plus g prime times f, and this is also because we can swap things around here with multiplication and addition, this is also f times g prime plus g times f prime. Okay, so and now we have two functions, x and sine x. This is f and this is g. And to execute the mnemonic, we make a table. And here we write f and here we write g, yeah, so everyone can do this. F is x and g is sine x. And we need, in this formula, see, we need f prime and we need g prime. So we write out those two. Then we find those. The derivative of x is 1, right? And the derivative of sine is cosine, right? And then to find this, we'll use this part. What do we need? We need f times g prime, yeah? So that's here, multiplying across. We multiply across, and then we need sine times g times f prime, and then we multiply here across, yeah? That's what it says in this formula. And then we add. So we multiply across and then add. So what do we get? X times cosine x plus sine x times 1. And this is the derivative of x times sine x. And we can make it a little bit nicer. This is x times cosine x plus sine x. Okay, and that's the answer. So really we executed this formula, yeah, just a reminder. Oh, here is the plus, and here is f was here, right? And g was here. And then f, we needed f prime. and g prime. Okay, so you see how it goes together. We can use this little table, yeah, the cross. Okay. So now it's your turn. Practice this a little. Then, because this is a bit more complicated, when you can simplify, you should simplify, yeah. So you should multiply out, yeah. Before you differentiate. So let's write it out again. So what is the rule? F times g prime is, and we wanted to write it the other way around, f times g prime plus g times f prime. So this is our rule. And now we do it, your turn, yeah? So we set it up as a mnemonic. Here comes f, and here comes f prime. Should know those derivatives, yeah? Here comes g, and here comes g prime. And then we multiply across, and then add. Okay, try these three on your own. Pause the recording, try these on your own, and then we compare. Okay, here we go. Okay, we write down x squared, and we write down cosine x, yeah? F, and this is g. And we take the derivative. Derivative of x squared is 2x. The derivative of cosine is sine, or minus sine. And then x squared times cosine x prime is, multiply across, x squared times minus sine x plus cosine x times 2x. And of course you can swap this around, yeah, because when we have multiplication we have the commutative law, and when we have addition we also have this law, yeah. So it could be minus sine x times x squared, or 2x times cosine x, and cosine x times 2x could be in the front, and x squared times minus sine x could be in the back, yeah. That is all correct. Okay, and then we make it a little bit nicer, so it's 2x cosine x minus x squared sine x. But the first part would be full points already. Okay, next one. Let's do it. So, f is g, that's a bit, call this h, right? That's confusing otherwise. So we write it out, and at some point, maybe we can go a bit faster, yeah? Maybe don't write f and f prime, yeah? Okay, so it's 1 plus 1 over x, and x squared plus 2. And we take the derivative of x squared plus 2. The derivative of x squared is 2x. And the derivative of 2, which is a constant function, is 0. Then the derivative of 1 is 0, right? And then 1 over x is x to the minus 1. So we can use the power rule, and then we get minus 1 times x to the minus 2. And then we simplify, multiply it out. So we get 1 plus 1 over x times x squared plus 2 prime is 1 plus 1 over x. More space here. Times 2x, and then plus x squared plus 2 times minus 1 times x to the minus 2, and then we make it a little bit nicer. We could even multiply it out, right? Multiply in the 2x, so we get 2x plus 2, because the cancels, right? Plus, and then we multiply in this one, that also cancels. That's minus 1, minus 2, and then we rewrite this one also. X to the minus 2 is 1 over x squared minus 2 over x squared. Okay, so, and then even better, so this is 2x, and then the 2 and the minus 1, can cancel something here, yeah? 2x plus 1 minus 2 over x squared. Okay, but if you get this already, it would be full points in a quiz, yeah? Okay, so we could also have seen this easier if we multiply that out here, yeah? So we could have multiplied out here, and that would have made our life easier, yeah? Okay, then next one, sine x times cosine x, a bit easier now. So let's do the cross, the table, and then f is g, and we need f prime and g prime. So this is sine, this is cosine, the derivative of sine is cosine, and the derivative of cosine is sine. Something missing here? Yes, minus sine, right? And then it's crisscross applesauce. So what do we get? Sine x times cosine x prime is sine x times minus sine x plus cosine x times cosine x. And then we make it a little bit nicer. This would be full points, yeah, but we can do better. So this is cosine squared. And as I said, the order doesn't matter because we have multiplication and addition, right? And then this is minus sine squared. Okay, and that would be then the answer. Okay, now we've learned this product rule. That's easy for you now, yeah? Now we step up our game. What about if we multiply with 3 functions? Now you should see that there's a problem because our product rule only works for 2 functions. Yeah? So what should we do? Well, the trick is to group, yeah, and you can group as you want because it's multiplication, but for simplicity I group like that. And then we execute the product rule for 2 functions, which we can. And then when we run into an obstacle, we make a little aside. Okay, so let's see how that goes. So yeah, let's do it together. You can pause anytime, right? So if you want to try on your own, go ahead. Okay, now I say I grouped it like that because the product rule only works with two functions. My first function is x times sine x. And my second function is cosine x. And then I fill in what I can. So I know the derivative of cosine is minus sine x. But here we run into a little problem. But now we see this is x times sine x. Well, for that we can use our usual product rule again. Yeah. So we make a little aside. I'll put away the question mark. So we make a little aside. What is x times sine x prime? So this is the product rule again. Yeah. So it's the product rule in the product rule. But now it solves. Take x here and sine x here. Then we get 1 here. And cosine x here. Then we do crisscross applesauce. And we get, what do we get? X times cosine x plus sine x. Did we have that before? No. Okay. So in this one, that was the missing ingredient, yeah? That comes here. So we get here x times cosine x plus sine x. Okay. And then now we can complete our original problem. And I write h prime because I said this function is h. What is it? And now we blindly follow the steps. There's x times sine x minus sine x. Better put a parenthesis. Plus cosine x times cosine x plus sine x. And now you might say, well, that's pretty long. And that's right. But we could do it by dividing it up into little steps. Yeah? And we could make it nicer, but we won't even do this here. That is totally fine. Yeah? Okay, so that's the advantage of using the table, yeah, because then you can make little asides and you don't get confused. Yeah? It breaks it down into small steps. Okay, so that was kind of the triple product rule, but we could solve it with the usual product rule. Okay. When f and g are differentiable and g is not 0, then we can also find the derivative of f over g. So f over g prime is g times f prime minus f times g prime over g squared. Yeah? So now careful. Now there's a minus here. Yeah. So before, if you remember, we had a plus here. And then the order doesn't matter, but now it matters. Yeah? The minus has to go with the f. Okay? So the product rule is easy to prove using the chain rule. And the product rule, and we will do this next time. And the quotient rule is generally algebraically difficult. So we should avoid it when we can simplify. Yeah? So when we can cancel out or multiply out, we should do that before and then take the derivative. Okay, here are some examples. And we'll do this together. How many? 1, 2, okay. So I write it again here. F over G prime is F prime G minus F G prime, there's a minus here, over G squared. And now the minus goes with the F and the G prime. Okay, here's an example. This is F and this is G. And again, we can use the table. But then we just have to, when we have to modify it a little. So here's F prime. Yeah, we need all that. We need G and G prime anyway. Yeah, that's what's on the top of the fraction here. And then need the crisscross here, where then there's a minus with F, yeah? So we can mark that. Okay, try on your own. The first one, pause the recording and try on your own using the table. And if you feel confident, you can also try the second one. Okay, let's have a look. So we write down F, we write down G. Again, there's an order now, yeah, because G is at the bottom, not at the top, okay? And then take the derivatives, you can do that now. The derivative of x is 1. The derivative of sine is cosine. And then we use the rule, so x over sine x prime is, and we use the table, the minus f, so minus x times cosine x. I start here, you could start on the other side also, plus sine x times 1 over, careful, G squared, so sine x squared. And then we make it a little bit nicer. Sine x times 1 is sine x, and we swap it around. Sine x minus x times cosine x over sine x squared. And that's it. Okay, so pause the recording, try on your own for the second function. Okay, let's do it. Okay, we draw the table. If you can do it faster, if you say I don't need this table, yeah, that's totally fine for me, of course, yeah. As long as it's correct, you will get full points, always, okay? But it makes it easier, okay? Okay, so now we have x and x plus 1, and the f gets a minus now, because we have the quotient rule. And again, the order matters now, yeah, that g is on the bottom. Okay, then we take the derivative. The derivative of x is not that 1. It's 1, right? The derivative of x plus 1 is 1 plus 0, right? Goes away. And then we execute the rule. Yeah, it doesn't fit. Okay, yeah, I zoom in. Out. I zoom out. Yeah. Okay, so x over x plus 1 prime, what is it? So we do the top of the fraction using the table. Maybe let's start with g. It's x plus 1 times 1. We can still swap, we just have to remember there's a minus. Yeah? Minus x, I have the minus, right, times 1. If that's confusing for you, you can still keep the old order. Yeah, and then over x plus 1, but now squared. So what do we get? We multiply out. So x plus 1 minus x. X goes away. So it's 1 over x plus 1 squared. Okay. Is that correct? I have a bad feeling. Let's have a look. Do everything right. Yes, correct. Okay. Back. Okay. So here we could use the quotient rule, but actually we can simplify this. Yeah, we can cancel, and then we should cancel. Yeah. So the trick here is simplify first. So that's an example where we should try to avoid the quotient rule. Yeah. So what is that? It's x plus 2x cubed over root of x, which is x to the power of, what is it? 1/2, right? Okay, and then we can distribute the bottom. Yeah, if you think about fractions, like 7 plus 3 over 8 is 7 over 8 plus 3 over 8. Yeah, we can always do that. So we can distribute x over x to the 1/2 plus 2x cubed over x to the 1/2. Okay, and what is that? We can cancel, yeah? So we could say x is x to the 1/2 times x to the 1/2, or this is x to the 1, yeah? And the laws of the exponents say this is x to the 1 minus 1/2. We combine that, plus 2 times x cubed minus 1/2. And if you're not familiar anymore with the laws of the exponents, you can look them up. Yeah, it's in week 1. They're all written down there. Yeah? Okay, so this is x to the 1/2, because 1 minus 1/2 is 1/2, plus 2 times x to the 2.5. And we write 2.5, and maybe we write even here 0.5, because that goes nicer with the power rule. And now we differentiate. So this is our function. Now simplified. Okay, so, and now we differentiate this one, which is easier to differentiate. Because we just need the power rule. So this is power is 0.5. We subtract 1. Well, first it goes to the front. 0.5 times x to the 0.5 minus 1 is minus 0.5. And then we split the 2 and then times 2.5 and times x to the 0.5. 2.5 minus 1 is 1.5. Yeah? And that's totally fine. Make it a little bit nicer. Oh, that's okay. X to the minus 0.5 plus 5 times x to the 1.5. Okay, and that's the answer, yeah? Okay. Next one. Now that's so great, we can do combinations of the quotient and the product rule, and we can do 2 product rules with 1 quotient rule, and so on and so on, yeah? Let's see how it goes in this example, yeah? I write it out again. F over g prime is f prime times g minus f times g prime g squared, and f times g prime is f prime times g plus g prime times f. And you should actually memorize these two, yeah? It's not so hard. Yeah? When you learn another language, you have to memorize thousands of words, yeah? We only have to memorize these 2 rules, right? That's easy. Okay. So, how does that go? Well, we should start with the quotient rule, right? And then once we run into a problem, we will solve that on the way, yeah? So, here's f prime, then we have g and g prime. And here we have a minus. And then we copy x times sine x and x cubed plus 1. And then we fill in what we can, so we can do x cubed plus 1. What is the derivative? It's 3x squared plus 0, right? So 3x squared. Okay, and here we run into a problem. So we have to do a little aside, right? We see it's a product rule. So if we do the product rule here, then we can fill in the gap and solve. And after some time, you can do this faster. You can also omit some details, right? So again, this is not a product rule. Careful. Oh. So we have x, and here is sine x. Okay. Pause the recording. Complete this one, and then plug it into the top, and then complete the top. Okay, what do we get? The derivative of x is 1, the derivative of sine is cosine. Then we complete this. So we get x times cosine x plus sine x. and this goes in here. So here we write x times cosine x plus sine x. And then we can complete it. So we can complete x times sine x over x cubed plus 1 prime. And that is I do the minus later, so I start here. X cubed plus 1 times x times cosine x plus sine x plus, or minus now, minus what? Minus x times sine x times 3x squared. Oh, parentheses here. And then all that over x cubed plus 1 squared. Let's not forget this one, yeah? I'll move the side a little bit down. Use my space properly, yeah? Oh. Okay. And that's it. Yeah, we can make it nicer, but that's full points. Yeah. Okay. And here it is. Okay. So that's complicated, but we can do it. Yeah. If we do a little aside. Yeah. Whenever we run into a problem, we make a little aside. Okay. And so I think that's okay for today. Let's go so far. What's left? 8. Okay, check functions. Okay, that's okay. So that's it for today. More on Monday. Have a great weekend.